In today's lecture, I will introduce the SAS Macro language. The SAS Macro language is a very powerful tool and is used to reduce the amount of regular SAS code. It can help to pass information between procedures. You can write dynamic and flexible programs and reuse them multiple times. The two key components are macro variables and macro functions. The ampersand and the percentage are two signs for macro language. The percentage sign is often used with macro function, and the ampersand is often used with macro variables. The percent macro statement begins the blocks of code to define the macros, and percent min statement to end them. You will also define a name for the macro following the same rule as variables. You can also specify the parameters in the parentheses to be used during the macro as needed. Macro variables are the variables which hold a value and can be used multiple times by a SAS program. Other than the system-defined type, they need to be declared first and called out later in the program. In general, there are two types of macro variables, depend on the scope in which global versus local. The system-defined ones belong to global scope. We can also define global macro variables too. These can be accessed anytime during the SAS session. We can also define local macro variables during the execution of the macro that defines them. The value for a macro variable can be a number, string, or date time, but the format of the value would be all character. The system-defined macro variables are created automatically when SAS started. We'll look at an example in SAS. Before starting the example, we'll first read in the Heart dataset. We will look at an example that shows the usage of sysday and sysdate 9. First, let's run the code. We created a title with day and date to go with the table, so we know when this table is created. To use them, we don't have to define them since they are already created automatically. The ampersand sign is required when you call the macro variables to indicate they are variables rather than just text. The user can create their own macro variables as well. Again, we'll look at an example in SAS. First, we will run the code for this slide. The rules for macro variable names are the same as it is for the regular SAS variables. %put statement, for example here, is what to use to define macro variables, and we use it in both examples. In the first example, we put a string as a name and add it to the second title to indicate who created the tables. In the second example, we apply a number to the macro variable age limit and apply it to where the statement as the age cutoff for the table. These two variables are all global macro variables. Macro variables defined outside the macro are global scope. Those defined inside the macro can be either global or local. We'll look at another example in SAS. First, let's run the code for this slide. We define var1 outside the macro and also define var3 inside the macro as global variable. We can see that the %put user statement tells us that those are global. We define var2 as a local variable. The put statement tells us that var2 belongs to the macro test, which indicate it is a local macro variable. When we apply these three variables outside the macro, we can see that var2, which is the local one, doesn't work. And we can see that right here in the log. The macro language function processes one or more arguments and produces a result. You can use those functions in both macro and open code. We'll look at some examples of string functions in SAS. First, let's run the code for this example. The uppercase function converts characters to uppercase. Substring produces a substring of character string with a specified position of length, and scan searches for a word that is specified by a number. In the example, we can see that uppercase function will turn all words to capital letters. This example can be seen here. The substring function returns a string from position 4 with length 7 from the original string. This can be seen here. And scan function returns the third word from the original string, which is word 3. And again, that can be seen here. One thing to note on this slide and the ones that follow is the examples are the same, but the line numbers are slightly different. Evaluation functions temporarily convert the operands in the argument to numeric values to be evaluated. Then they perform the operation and convert the result to a character value. You can use the evaluation functions to make character comparisons, evaluate logical expressions, or assign numeric properties to a token to be used later. Again, we'll look at an example in SAS. We'll first run the code for this slide. In this example, we can see without any function, total is just a string as 100 plus 100. But the eval function returned a calculated 200 value to total 1. However, eval cannot handle floating numbers. The log shows an error message and total 2 is not created. syseval solves this issue and returned a calculated value 200.1 to total 3. And so we can see the total 200 here in the log. Here is the referenced error, and here is the 200.1 or 200.01. When we want to get information out from a data set to be used later in the program, we can create macro variables during the data steps or proc-SQL. Then we can add it to the data set by data steps or proc-SQL. During the data sets, system put function aims to get information and to put it into macro variables, and system get function aims to put macro variables into the data set. During proc-SQL, select into statement can get information from the data set and put it into the macro variables. Let's look at the data steps first, using an example in SAS. Again, we'll first run the code for this slide. In this example, what we want to do is add a new variable for mean number of cigarettes smoked by gender back to the original data set. First, we create a data set with those means by gender. Then we created two macro variables for mean for different genders. Then we put those values back into the original data set using the function sysget. Note here that the system-get function uses quotation marks rather than ampersand to call the variables. And we can see that here. ProcSQL uses less code compared to data steps to get similar information into the macro variables. Let's look at an example in SAS. First, we'll run the code for this slide. Select into statement with the mean function puts means into two variables by gender. However, we are not clear which mean is for which gender if we don't really know the order of the variable sex. So to be sure about it, you can create them separately with where statements so you know that mean 1 is for female and mean 2 is for male. And we can see that difference of the output here. When you want to use the same or similar program again and again on different variables or even data sets, the macro program can be really useful. Here we can use some simple macros to do the means procedure repeatedly on different variables. And again, we'll look at an example in SAS. We'll run the code for the first part of the example first. The first way we can see in this example is to use a do loop. First, we define some macro variables to represent the variables we are interested in, then create a macro with do loop with proc means in the loop. To combine I together with the var to indicate the variable name we wanted, we need to use 2 ampersands before var and 1 before I. The log shows the usage of single, double, and triple ampersands. If we use a single ampersand, the value we get is variable 1, which is just the values from var and in combined. If we use triple ampersands, we get the value for variable 1, which is the result diff. Here we use double ampersands, we get age at start, which is what we wanted, which is the value of var 1. Dim is a parameter to use during the macro. It can be replaced when you want to call the macro. Here we replace it with 3 when we call the macro in this macro. In this example, we want to check var 1 to var 3, so the program will loop from var 1 to var 3. We could also see an alternative way. The alternative way is to find a simpler macro with variable names as the parameter, and we just need to specify which variable we want to look at one by one. We will need to call the macro once for each variable. The two macros produce the same results. Next, we'll look at an example to produce a demographic table with means and standard deviations for numeric variables using macro with 4 parameters. First, we'll run the code for this slide. Data is for dataset name, var is for variable name to be analyzed. Class var is for class variable name, and label is for a label to use for the variable. During this macro program, first, we get mean and standard deviation for the variables by group. Then we create a new variable to put mean and standard deviation together as a single variable. You can see that here. Then we transpose the data from long into wide format for the variable stats and add labels to it. Notice we can see these here. The last step is to set the data set together with dataset final to combine results from different variables. We see that here. We repeat the macro on 3 different variables. Then the dataset final has the statistics we wanted for all variables. Stop is an action in the data step. It tells SAS to stop processing the current data step immediately and resume processing statements after the end of the current data step. We can then use the dataset final to produce a table for demographics by gender. We'll first run the code for this slide. We want to display gender rather than column 1 to column 3 as the label for gender and add total counts for each group. We use proc SQL here to create 3 macro variables to be used in the proc report as the count. And so we can see that here. The %let function here trims the leading blanks we can see for total. There is no space between the equal sign and the count, but there are spaces for female and male. Debugging is important in any program language. As we have seen during the course, the SAS log is where you can find note, warning, and error message. It's really helpful to check log if you are unsure about your program. Compared to the single data step or procedure, debugging can be hard for macro program. There are 2 options that can be used to help along the process. Imprint helps to see the translation process from a macro program to use a regular SAS statement and to write it to the SAS log. mLogic tells the processor to trace its execution and to write the trace information to the SAS log. SAS can also scan the macro when you define it. If there are any issues with the code, the program won't compile and error messages will be written to the SAS log. For example, if we forget to put the % before 2, SAS cannot find %2 to be paired with %do. We can see the errors printed in the log and figure out what the issues are. This is the end of the slides for the SAS macro. Please let me know if you have any questions. Thank you.